Hello, good afternoon, everybody. Welcome to this last hour of presentations today. Right now we'll have Alistair Adams from the Qt company that will talk to you about Qt in the automotive world. Alistair?
Okay, can everyone hear okay? Oh, yep, that sounds good. All right, so yeah, as I said, my name's Alistair Adams. I do product management on Qt in automotive world. I'm just going to talk a little bit about the state of Qt in automotive and where we're going and what the future looks like. So let's see, I haven't pushed with these things before. Look at that. So while I was sitting around here procrastinating, trying to figure out what I was going to put in this slideshow, I went through all my Facebook feeds and read all about, who was the worst candidate, who was the best candidate, and went through my Instagram, and then I thought, all right, well, that leaves, went through my Strava, and then that kind of left LinkedIn, and I was going through LinkedIn, and what do I see? Someone's putting up a talk on, pointing to an article talking about all infotainment systems suck. So I think some of this has come around because it has taken a long time, so I'm going to talk a little bit why that feeling is there, and part of that feeling has led people to think, well, maybe I really want to bring in my Android Auto or my Apple CarPlay device instead. But in our view, my view is that if you can actually integrate everything into the car, you can get a much better experience than those two types of screen reflection technologies can provide you. And there's a lot of people who are using Qt to do that, so we'll talk a little bit about how they're doing that. So part of the problem of why I think so many infotainment systems suck is this little diagram that I put together for another show I went to, and when I did it I was a little bit nervous about putting this together, and you'll see why. So typically what happens, and used to happen anyway, may still happen, is as a spec gets written, that's, whoops, too many input devices, let's use this one. And that's typically done by the OEM, and that gets delivered to a tier 1. But there's this sort of brick wall between the OEM and the tier 1. And the spec gets chucked over to the tier 1, and that's kind of what happens. So as I said, this was a bit that I was a little bit afraid about when I gave this presentation, and afterwards somebody came up and said, well, I really loved your presentation, and I really like that brick wall. And that person was from an OEM. And I find that this tends to resonate with the people who are building infotainment systems. So that type of mechanism works really well when this is your IVI system. One line of text and a bunch of buttons. You can pretty much write that in a specification, give it to anyone. You know it's going to come back right. But you start to get to something like that, and it's just not going to work. You're going to write the spec, it's going to come back, and you're going to put it in the car. You're going to try it out 6 months after you sent your spec out, and you're going to say, well, that button, actually, it probably needs to be a little bit bigger so it's easier to touch it while I'm driving down at 80 miles an hour. And when the sun comes in, I probably should change the shade of that a little bit. And that becomes what's called a change request. So what we say is that to make these things better, you need to have your designers and coders working side by side together. So you eliminate that brick wall and work together. And just to illustrate the way things were, so when I first came into the industry in 2009, this is what happened. The OEM will do some UI prototyping. They'll have a design team, will come up with some mock-ups of what they want things to do. They'll show it in front of their management, and they'll get sign-off, say this is great. So that becomes a specification. So that then gets sent off to a tier 1. And then the tier 1 will do some implementation. And at some point, the clock starts ticking and time goes by. And then several months later, you may get a delivery. And then what's going to happen is you're going to start reviewing, just like I said in the previous slide. You're going to look at it and you see whether you like it or not. And you're going to realize that you didn't think of everything, you didn't think of every corner case when you did your design. And then that then becomes a change request. And the tier 1 is going to do some cost estimate. You're going to do some negotiation of what that cost will be. You're going to come to some agreement. And then it's rinse and repeat. And after you've done this a few times, you're going to not bother trying to do any more change requests because it's just going to take too long. And that goes back to why you get articles like the one you just saw. And then there's another problem in this, is that you typically, I've stole this from a presentation earlier. If anyone was paying attention to some of the earlier tracks, you'll see this came from the Harman talk. But typically you've got these 7-year overlapping programs, and the first one will get awarded to tier 1, and then when that gets started, you start thinking about what's the next one going to be, and that gets awarded to a different tier 1 supplier. For some perverse reason, this is the way that the automotive industry likes to work. The problem with that is every time you're starting from scratch again and again, you're not building on top of what you already had. And that leads to increased costs, and again, the things don't get better. I mean, imagine if Windows or iOS, every time they did a new release, they started from scratch again. You just wouldn't get anything really good. So the good news is that the automotive industry is changing. They've recognized that this is a problem. Some are changing faster than others. And we actually are working with multiple OEMs who are starting to take ownership of the HMI that they're doing, and they're actually using Qt to build that. So what we're doing is looking at what sort of tools that we can put together to really speed up the development of HMI, particularly in the automotive field. And before I just go a little bit of history about how long Qt's been going in automotive. So it's actually been there for quite a long time. So one of the first companies that started using Qt in automotive was actually Magneti Marelli way back in 2008. So that's almost, well, 8 years ago, 9 years ago almost. A bit later, a couple of guys from Tesla kind of walked up to us and said, well, you know, we want to look at your technology. Our CEO says you should take a look at it. And this was back when I was working when Qt was owned by Nokia. And so we helped them get up and running on an NVIDIA Tegra 2 with the OpenGL acceleration with Qt. So that was a version 4. There's actually, at this point, millions of cars running on the road that actually have Qt inside. You'll find it in GM cars, you'll find it in some BMWs, and there's a ton of others that I haven't mentioned. And then we get to this is one that I particularly like because this really shows you all the great things that you can do with the Qt and the real results. This was an article that I pulled off, Digital Trends. So I know we've probably got some people from Ford here, but I know they had a lot of stick from the industry about previous ones, and this one was built with Qt, and you can see the quote there that it performs really well. So that's one thing that we like to do with Qt, is make sure that everything performs really well. So let's look at some of the pain points in how you go about building an IVI system and some of the things that we're putting together to make this actually work. So I think there was an earlier talk today by Johan Thielen. He was from Pelagico. He's one of the companies we worked together when we were building the automotive suite. He gave a big overview of their approach to doing things, and I'm just going to talk about some of the things that we're going to do to build on top of that. So I think one of the first things is that how do you get from the designer workflow into the actual software? So many people, designers, are using tools like Photoshop to do the design work, and at the end of the day, you need to get that out into QML. So one of the things we're doing is looking at is using a tool called PNG Express to actually export from Photoshop, taking all the different layers, and just coming up with what the best practices that we recommend for how you go from Photoshop into the QML templates. And one of the key things about this is it has to be not quite a two-way process, but you've got to be able to go back into the design tool, do some modifications, and then be able to re-export them back and not have to redo a whole bunch of work again. So that's one of the key things that we're going to be looking at in the next release. So a lot of these things are going to be targeted for a 5.9 time frame. So again, this is another thing that traditionally the HMI has been one big application. One of the problems of that is it can be quite fragile. So if you want to change one aspect in the UI, you don't want it to. So for example, if you're changing the multimedia player, you don't want to infect the tuner or any of your settings. Because there's always, if it's one big app, there's always possibility that a change somewhere can impact other things. Regionalization. If you're deploying vehicles across the world, to Asia, to Europe, to the US, there might be differences. If you can split things up into different applications, then you can have one variant of the app that would work in Europe, another one in the US, and so forth. It also makes, if it's one big application, it also makes it hard to do over-the-air updates. So if you need to update just the media player, then it's easier to do it if it's one single app rather than if it's part of a big monolithic application. So to solve that, in the application suite, in the Automotive suite, we have an application manager which handles all that. So it gives you the ability to download, install, validate, delete it, and manage the applications. And together with that, we have a system UI that handles notifications. So there's a way for all the applications, if they need to raise notifications, they can raise it to system UI. And because you have multiple applications running on there, there's a Qt compositor to put it all together. So that's all great. So one of the things we're doing there is adding the Qt Creator integration, so that from Qt Creator you can actually build and run applications within the application manager. And then the other thing is now that you've got the application, if you split everything into applications, there's one little downside there, and that is that with every application you're going to have UI assets for what do my controls look like, what do my graphics look like. And now instead of having just one copy, each application is going to bring in their own copies. So that's going to occupy space on the file system, it's going to occupy space in memory and perhaps in video memory. So we're going to address that issue as well, so that you can now have shared resources. So that if you've got the same UI resources across multiple applications, they can share that, and that's going to be making things a lot more efficient for the implementation. So you don't lose out on that. So deploying on the target, it still surprises me that a lot of way that people find out how do they deploy their application on the target. Well, they just rebuild the whole system image together with their application, stick it on either a flash card or flash down through a cable onto the device and reboot it and try that. And that's going to take you minutes, maybe tens of minutes depending on the system. So with our existing boot to Qt system, we've always had the capability there that you can just from within Qt Creator hit download, run. You can do debugging and you can run profiling all from within the Qt Creator IDE development environment. So we're going to enable exactly that whole same experience, but at the application level, so that you can develop applications that run with the application manager. So that's going to give you a similar experience you have as if you're going to be developing applications for your smartphone, but you can do that in an automotive environment. So other things that we're doing, big thing that everyone's doing right now, supporting multiple screens. We already have support for multiple screens just coming in the 5.8 that's about to be released, and supporting that in the Qt Wayland protocol. Also supporting multiple touch, so the multiple screens can have multiple touch as well. So if you just do stuff out of the box, you'll find that your secondary screen, when you start touching on that, it actually ends up affecting things on the first screen, so you've got to change your whole coordinate system to handle that. So that's all coming in the 5.8. Wrong one. The other thing that's really important also, IVI shell is something that's really big in automotive. A lot of automotive companies use that. So by supporting some of the IVI shell protocol from Wayland, it means that you can bring other third-party apps into the system and run it with the Qt compositor and application manager, and that would make that a lot easier to support. Okay, so we talked about download and run on the target. The other thing that typically happens is in the program is that targets are either late to be built or in very short supply, so you can't have every single engineer sitting there developing on the actual target. So the way to get around that is by having on-host emulation for the whole system. So just like when you're building an app for your smartphone, you can test it on your development host. You get a little picture of a smartphone with a sort of the Chrome of the smartphone, and then you just see what you see on the screen comes up on the host. So we can do all that already with the boot to Qt. Now we need to add in the Wayland support, so you can add in simulating the compositor as well, and also multiple screen support. So these are all additional things that are all down in the pipeline. So now you can do on the development, on the target support development, and also simulation on the host. And then one of the key things when you want to do simulation on the host is how do you actually really simulate the signals that are coming from the car? So what about the door state, the temperature, the fuel gauge? All these things need to be simulated. Maybe the radio tuner. So one of the other main components of the Automotive suite is what we call Qt IVI. So these are the APIs that are used to talk to the lower level, the middleware of the platform. And the whole point about the Qt IVI APIs is that at the application level, everybody has the same APIs, so that you can have you can take that application can talk to lots of different implementations and middleware, so long as they all match that same API. And what we're showing here in this diagram is that you know, these you have these different backends here. So, well, you know, having a green, it kind of works. A green pointer on green doesn't really work. But the idea is that you've got this API. You may have an API that's going to talk to your, say, your environmental controls. So you could create a stub for it before you've actually implemented something. And then you can also have the complete implementation for one particular backend. And if you're running on a different platform, somebody else, a different tier 1's platform, you can have another implementation. But here's the key: is you have an emulator. So what the emulator is what you would use on the host, and then by being able to plug in and simulate the signals on that emulator, you can actually do full testing on the host without having the real target, without having a real vehicle. You can simulate conditions that you wouldn't normally get on a test signal. So what's it going to be like if my temperature reads 50 Celsius, for example, or minus 50? Does my UI work properly? And the other thing is you can also make that scriptable, so you can put in test scripts for doing QA testing. Okay. So the next thing is SDK creation. So what we find is that you set up a program. You've got a lot of engineers working on one of these programs. How do you get them all working on the same version of the software? So what we're going to do is let the customers, we're going to give them the same toolkits to build their SDKs that we have for building our own Qt installable SDK. And by an SDK, what do we mean? So the SDK obviously includes the Qt Creator. There may be customer-specific plugins that they've written for their own version of Qt Creator. They may have their own particular version of Qt, because quite often in a program, you might want to settle on a particular version of Qt, and then, well, the bug comes along and you need that bug getting fixed. So rather than upgrade to the next version of Qt, you're going to want to actually just take that patch. So you might be maintaining a specific version of Qt with a specific set of patches just for this particular program. There'll be customer-specific UI assets and any specific code. So that can all be put together in an installer that is specific to that program. And that's going to give a lot of benefits in terms of just maintaining how do you make sure everyone's on the same version. So that's going to be very useful for many of these big programs. So as I say, that's going to enable easy distribution, just so that everyone's consistent developer environment. And then there's a different kind of SDK. So that once you've got your program up and running and you've got your IVI system going, you may want to have a third-party ecosystem, and you have an application manager already in there. So what if you got your Spotify's or your Pandora's or other people who are providing systems, and you want to say, hey, you know, I would like to have an app built for our head unit, our IVI system. How do I go about doing that? Well, here's the ability to distribute Qt Creator and the header files, everything they need to go build that very easily and just build that whole ecosystem up of additional applications. So that's some of the key things. There's a couple of few other things that we're adding in there. State charts. There's a state chart machine. The state machine framework has been part of Qt for a long time, based on the SCXML standard, which compiles to C++, or you can load it at runtime. And what we're adding in the next version of Qt Creator is an editor, a visual editor for editing state charts. So you'll be able to create the state charts and then go to SCXML and do the full generation, all from within the Qt environment. So that's something that people have been asking for a long time. So it's really great to have that aboard now. And then just a few other things that we're working on. So we already have a virtual keyboard. So there's a bunch of enhancements to the virtual keyboard that we've identified. One little example is right now when you have the virtual keyboard, it pops up in front of all your other UI, and sometimes you just can't see the text input field that you're actually trying to type into. So what some people want to do is just make the virtual keyboard full screen, which especially when you've got keyboards in cars which are kind of long and thin. And so just making it easier to do things like that. We're doing a lot of work on instrument clusters and fast boot. There's a demo downstairs. I don't know if anybody's seen that, which shows how fast you can do it. And the main reason for doing that is to show that it's not Qt that's slowing you down from doing a fast boot. It's quite possible to boot under 1.5 seconds in Qt. So it all comes down to your OS and your memory and your U-boot. And then the other things they're working on are doing integrating the cluster and IVI. So just to quickly summarize the main key features of things that we're going to be seeing coming. The main thing is so doing from designer to software workflow and making that nice and smooth and quick and efficient. Making app development within an IVI system really robust with an application manager and providing all the tools to be able to download to the system. Being able to simulate on a host rather than if you don't have the target or the target in big volumes. And then also doing on-target deploy. So if you do want to test things out quickly on the target, just push a button on Qt Creator and it downloads and runs and it's running on your target. Multi-display and compositing, we're going to continue enhancing that and making that work really well. And then the SDK creation. So that's it. And our goal is to make IVI rock so that that first slide that you saw, you won't see much more that that is going to go away, and people are going to say that IVI systems are much better. But based on some of the things that I see that are going on with some of our customers, I think there's a really great future ahead in IVI. So thank you.
Thank you. I guess we have time for a couple of questions.
Yeah.
When you're bundling together your SDK, the first component was the Qt Creator, and obviously there's a lot of different versions of it. And in my anecdotal experience, at least, the MinGW version, you don't have to have external. You don't need to bundle in external things like Visual Studio, for instance. So in a way, that would be the nicest one because it's kind of standalone. But in my experience, it has certain bugs that say the Visual Studio version doesn't have in some cases, oftentimes relating to OpenGL or things like that. So how do you decide which version to use, or do you have any sort of thoughts on that?
Well, I think the real point there was giving the end customer the ability to have a tailored version of a Qt SDK. Excuse me. Because if you download the Qt installer, you're going to get our standard versions of Qt to install, and what we find is some customers are actually building their own Qt Creator plugins. So how do they go? And then they've got their own customized version of Qt because they might have selectively taken some patches from a newer version. So how can they create? The problem we're solving is how can they create an SDK that they can distribute internally to their developers, so all their developers have a consistent development environment. So everyone's on the same version of Qt, everyone's got the same version of Qt Creator. And one of the other challenges we have right now in the Qt Creators is that the plugin APIs are private, so they tend to vary slightly from one version to the next. So it makes it harder to match up your plugin versions with your Qt Creator version. Yeah.
So do you work with Microsoft to bundle in, Visual Studio? So just a follow-up question, so would you work with, say, on your level of the SDK, sort of the SDK implementation level, would you work with, say, Microsoft to bundle in the Visual Studio and make it more smoothly integrated cross-platform? I mean, so because Visual Studio's on Linux now, but I don't know if it would be well supported on all platforms that Visual Studio supports. So.
Wow, I'm not sure I can answer that one directly. I mean, this particular side, I mean, is that a more general question I think you're asking there, and just in general, and how we create, or how do we support Visual Studio? It sounds like
it seems like it'd be an opportunity for tighter integration there between Qt and say Microsoft, because right now it's like they're two domains, and you can use them together, but it's not very tightly integrated, it seems like.
Well, I'm looking at this really more from the automotive perspective, and on that side, there's less people. In fact, I don't know if there's anybody really using Visual Studio. So, I mean, everyone, at least that I'm aware of. If you're on automotive and you're using Visual Studio, we should have a chat afterwards.
I'm not, but I know some people are. People are.
Yeah. And that sounds like it's probably a question more for our whole Qt Creator team. They'll probably find someone to talk to on that. Yeah. This sounds like you got some good questions.
Okay, thank you.
6 seconds left.
1 minute?
4 seconds left.
4 seconds.
Anybody else?
One very good question.
Yeah, go ahead.
No, sorry. Wait, we need. Yeah, we need to prepare for the next session. Sorry. You can maybe take the question directly.
All right, thank you.
With Alistair.